Hello guys, today we're going over problem 2.24 from the Strengths of Materials textbook. So the problem states the steel frame with Young's modulus equal to 200 gigapascals shown has a diagonal brace BD with an area of 1920 square millimeters. Determine the largest allowable load P if the change in length of member BD is to not exceed 1.6 millimeters. All right, so we know that the deflection in BD is equal to 1.6 millimeters. All right, so since this is a metric problem, everything is going to be so much easier if we turn everything into the base units. This is why I think the metric system is so stupid, because you never get the values in the units that you want. So our deflection is 1.6 times 10 to the negative third meters. All right, so our equation for deflection at BD, or here, let me just write it on a new line. The equation for deflection at BD is equal to the force times the length over the area times the modulus of elasticity for BD. So if you want to know what the force is, we can just rearrange this equation for the force. So the force BD is equal to the modulus of elasticity of BD times the area of BD times the deflection of BD divided by the length of BD. All right, so this is just plug and chug. So modulus of elasticity, so 200 gigapascals is 200 times 10 to the 9th pascals. All right, multiply the area. So what was our area? So 1920 square millimeters, that's going to be 1920 times 10 to the negative 6 square meters, because metric's really stupid. All right, and then our deflection of D at BD was 1.6 times 10 to the negative 3 meters. And then the length of BD, well, you just calculate that over the side over here. The length of BD, this is just Pythagorean theorem. So the square root of 5 squared plus 6 squared, square root of 5 squared plus 6 squared, and that's equal to 7.81 meters. So we'll divide this by 7.81 meters, and that's going to give us 78.67 times 10 to the third newtons. All right, so we calculated the force in BD, but this is not the final answer, because the question is asking what is P. All right, so let's draw a free body diagram of joint B. So we have joint B over here. All right, so we got a positive value for force BD, so we know that's going to be in tension. So here's P, D, right? And we know that P is pushing on C, which is pushing on B. So we would have P going that way, right? And now, let's see, and then AB has to be pushing up to counteract the downward motion of BD. So here's AB. Here, let's make sure that's P. Okay, now to get P, we can sum the forces in the x direction. So we're going to sum the forces in the x direction. So that's equal to positive, and the x component of this force is just going to be 5 over the length. 5 over 7.81 times PBD, and then minus P, because it's going in the opposite direction, and that's going to equal 0. All right, solving for P, we get P is equal to 5 over 7.81. And then we can just substitute this in for PBD. So times 78.67 times 10 to the third is equal to 50.4 times 10 to the third newtons. And that's the same thing as saying 50.4 kilonewtons. That's our answer.